Today we are going to go over 8.10 Part 1 Taylor and Maclaurin series. We learned Taylor and Maclaurin series before. So Taylor and Maclaurin series are used to approximate any function f(x). The nth term Taylor polynomial is given by fc plus fc prime times x minus c until the nth derivative over n factorial times x minus c to the nth power. For a special case, if c equals 0, we call it Maclaurin series, f of x approximately Pn of x. When the n goes to infinity, this approximation will be equal. So fx equals to the Taylor series centered at c, given by the same series, and this term, the nth term, which we call the general term. And the series, when c equals 0, we call it Maclaurin series. Let's have a look at some examples. Find the general term and Maclaurin series for function f of x equals sine of x. And then we take the derivative. C equals 0. We need f0, derivative, double derivative, and the fourth derivative, etc. And after we plug everything in, f of x will be approximately equals x minus x cubed over 3 factorial. X to the 5th over 5 factorial minus x to the 7 over 7 factorial. And if you look at here, this is the Taylor series. And how do we find the general term? So when n equals 0, that's x. 1, give you this term. When n equals 2, that's this term. It's an alternating series, so it will be negative 1 to the nth power, or n plus 1. Because when n equals 0, it has to be positive, so we are going to pick negative 1 to the nth power. X to the, if you look at the power here, it's all to the odd power, so it's 2n plus 1. So when it's odd, it will be 2n plus 1 or 2n minus 1. Which one is right? When we plug n equals 0 in, it will give us x to the first. So this will be our general term. Given sine of x, if we know sine of x based on the properties, how do we find sine of x squared? So we just plug in x using x squared. So f of x equals x squared minus x to the 6th 10th over 5 factorial 14th over 7 factorial. And the general term will be given by x to the 4n plus 2 over 2n plus 1 factorial. Okay, this is what we learned before. Next page, we are going to go over some very important functions. So let's have a look at this table. In the future, we can use this formula directly. We don't have to derive it. So first one, 1 over 1 plus x. The first term is 1, common ratio negative x. So the general term, negative 1 to the n times x to the n. E to the x, the general term, x to the nth power divided by n factorial. Sine of x is oscillating, and to the power of 2n plus 1, which is odd, because all the even terms is 0. So this is always odd. And cosine of x is always going to be even. It will be negative 1 to the n, x to the 2n factorial. And the next one will be arctangent. Arctangent, the formula is very similar to sine of x. The difference right now is no factorial in the denominator, just 2n plus 1, only the odd terms. So based on this, and we are going to use these formulas to solve some more complicated functions. Let's have a look. How do we find the first 4 terms of the Maclaurin series? Given e to the x, fx equals e to the x times cosine of x. So e to the x, the general term, x to the n over n factorial. Cosine of x, negative 1 to the n, x to the 2n over 2n factorial. So now we are going to multiply these two series. So e to the x is 1 plus x squared over 2, x cubed over 3 factorial, 4 factorial, and x to the 5th over 5 factorial. And then we multiply cosine of x, which is 1 when n equals 1. 0 is 1 when n equals 1. Negative x squared over 2 when n equals 2, which is x to the 4th over 24. How do we multiply them? We just multiply the whole expression by each term. Make sure you align all the same power together. So first we multiply the whole thing by 1. Just copy everything down. Next, we're going to multiply everything by negative x squared. So we align the terms. So it's negative x squared over 2 plus minus. Next, we multiply everything by this one. Give us x to the 4th over 24 plus x to the 5th over 24. Next, we're going to add all the terms together. The first term is 1. Next is x plus 0. This gives us x cubed over 3 minus x to the 4 over 6. So we only need the first 4 non-zero terms. So these are the first 4 non-zero terms. So on the test or quiz, if you need another term, you just keep adding some terms and you will be fine. Let's look at the next example. Find the first 4 non-zero terms. On Maclaurin series, for this f of x equals e to the x over 1 plus x. If you look at this equation, e to the x over 1 plus x. And sometimes we did this problem before. This problem, the difference right now is the numerator is x squared. So in this case, if the numerator is already a polynomial, we can directly to the n and we move the x squared inside. However, if this is e to the x, we cannot do the same thing because e to the x is not a polynomial. Maclaurin series is always a polynomial. You can write that way and do the multiplication. You can write as e to the x times 1 over 1 plus x and express each as a series and multiply them. Or we can use long division. So e to the x over 1 plus x. As we know, e to the x is 1 plus x squared over 2, x cubed over 6, x to the 4 over 24, x to the 5th over 120, divided by 1 plus x. Be careful here because the numerator is x is increasing order. We want to make sure the denominator is also increasing. So first we put 1 here, it's 1 plus x. We do the subtraction. We'll have x squared over 2 plus x cubed over 6. Next, we put x squared over 2 here. We have x squared over 2 plus x cubed over 2. We do the subtraction. We have negative 1 over 3 x cubed. Next, we put negative 1 over 3x cubed. The subtraction give us x to the 4th 9 over 24 plus. Next we put plus. So this is our first 4 non-zero terms. We can stop right here. This will be our final answer.